Now recording. So Shrikant's going to talk to us about Cord, give us an update in a couple of minutes, but I wanted to hit a couple other topics first. One is with tomorrow's Cord and ONOS board meeting, we're reminded that we need to produce a better documentation of who's contributing so we can attribute contributions. Stats and data would be good if we had that. So we'll go, we've only got so much available by tomorrow, so this is more looking forward. So we'll take this up in more detail at a later time and be thinking about what data we could be showing people. We have very limited data and stats from Slack where a lot of activity happens because we're not paying for it. And they're very protective of their stats. Any other ideas what we should be doing? I mean, I can call Garrett, but I would be doing it by hand, and I don't see a good way to get stats on who's done some things, but I don't know Garrett well enough.
Yeah, I think if you spend a bit of effort, Garrett has an API that you can pull this stuff out of, and you can sort of formulate the statistics that you want from that.
Good.
But it just takes some time for someone to write scripts that will do that.
Yeah, I found the GUI page for it, but I realized it was going to take me forever.
How does ONOS do
it? It is for the statistics. We have set up something for ONOS that fetch commit and group them by company name for ONOS. So
we can. So you've got the
Garrett
scripts for ONOS. Okay. We should.
Yeah. So Brian, Luca, and Ayaka did the backend part. I took care of the client side. We can maybe reuse a big part of that.
Good.
It should be similar.
That would be good. Any other ideas?
The other thing is the mailing list. I'm not sure if it's possible to pull statistics.
I didn't go look at the mailing list. We tend to use Slack more than the mailing list, but I'll go look at it and see if there's anything easy to get from there. We've got, I don't know, 2,500 Slack messages in a week. So I know we're busy. And it looks like on the order of 50 people are active at any given time. So, all right. So that'll be an item for next time to pursue that, but I just wanted to raise everyone's awareness of it. Second preliminary item is state of the release. So I saw there was another candidate cut very, very recently, last night or this morning.
Yes.
But you're the guy, Jonah.
Yeah, so ONOS 1.8.2 was released. It's the ONOS spec that we were hitting. And the Cord 2.0 branch is now pointing to that Docker image. So in my manual testing, it worked at least until the end of the automation. So it seems to be, we seem to be in a better place than we were before. The thing that I see as remaining is just updating the documentation in the repository. So the quick start guides that we have someone still needs to go through them and update them. And I think that needs to be done before the release, because when we release, they will be tagged with the version.
Okay, so good. So Andy, we need Andy and David as primary here. So I see Andy on. Quick start documentation. How close are you?
Yeah, I think the quick start that describing Cord in a box is in good shape, but I will make another pass and just see if there's any errors that have crept in there. David said he wasn't going to be able to make the meeting today.
Okay, so the other issue then is quick start physical, which is the more...
Yeah, it still references like SSH into the XOSVM and stuff like that, which doesn't exist anymore. So I feel like someone needs to go through the guide and just make sure that all the commands work and that they can bring up Cord to the end of the document, because I haven't gone through all the document, I've just done to the end of the automation. So I don't know who that person is going to be, but that's the one thing I can see before the release.
All right, thank you, thanks, good point.
So at the last stand-up, David said he was going to take a pass through it.
All right, so we'll make sure, this is what you get for missing a TST meeting. We'll make sure David is on the ball with the documentation. Anything else?
Oh, so I just wanted to say that I've been running Cord in a box on Cloud Lab using the Cord 2.0 branch, and it seems to be working.
Good. All right, so let's assume the best there. It'll be, within a day or so. All right, so I asked Srikanth to talk about Cord because in various conversations I have been having with different groups, everyone needs monitoring data of some kind, and there was a very uneven awareness of what he's been doing. So I wanted him to spend just a few minutes, and people can ask questions, just so people know that it's there. It may be something that you can use, but perhaps more importantly, it is something you should be contributing to, because we need to populate every hardware and software element in Cord with probes that will feed monitoring data into the monitoring service. The monitoring service, by the way, is itself started with Ceilometer, and so sometimes it's easy to say, oh, it's an OpenStack thing, but it's actually evolved quite a bit from there. It's a set of microservices working in concert. It's also multi-tenant, so it can serve many, many different analytic engines on top of it, each able to see some subset of the data. Clearly, if you've got admin privilege, you can see all the data, but it's designed so that you get access to what you have permission to access, and then you can run whatever analytics engine you want on top of it. It's supposed to be a narrow waist. So let me, with that, give Srikanth a few minutes to talk about it, just so everyone understands what's there. Srikanth?
Sure. Yeah, thanks, Larry. So maybe before jumping into the monitoring service details, let me give a brief introduction of this analytic Cord solution for those who are not aware of this project so far. So as Larry mentioned, the key goals of this initiatives are twofold. The first one is to provide the deep programmable observability into various network elements that we have in Cord. The second element is to enable, second goal is to enable closed loop control on top of this whole platform. So as you can see the screen, the picture where we are depicting the Cord solution as a combination of 4 key elements. So the first and foremost is the bottommost one, the programmable probes that provides deep observability of what's happening inside your network. So we are hoping to have these probes at each and every element inside Cord. That includes both hardware elements such as disaggregated access devices or core devices, compute nodes, storage nodes, fabric, white box switches, any element that has enough data about the subscriber traffic. We wanted to have the visibility. Not only at the hardware, we wanted to have the visibility for all the virtual and software elements. So for example, the virtual switches that are running on the compute nodes, or even the service VNFs running on this whole infrastructure. These also should have the programmable probes such that we have end-to-end observability, like starting from the infrastructure all the way to the services. So that is the key functionality of these probes at various elements inside the Cord. Not only that, more importantly, these probes we are expecting to provide some programmability or flexibility to control what to observe, when to observe, and where to deliver that observed data. So instead of being enabled and observing everything going through these elements, we wanted such type of flexibility. The second element in this solution is the monitoring as a service, which I will talk more in the follow-on phases. But at a brief, this is a logically centralized service, which the key functionality of this element is to abstract and provide a unified interface to program and observe these underlying probes. Thereby it decouples the higher layers from the underlying targets. That is one of the key goals of this centralized layer monitoring as a service. The third element in this solution is the analytics engines. So these are the components that digest the observed data coming from the underlying probes and perform real-time and batch analytics over the data by applying some context-specific intelligence to get deep insights of the network. So these applications and engines can be simple open source versions or could be a sophisticated closed proprietary ones. And so we wanted to have both of them to make this platform usable. So if you see the picture, there are the outcome of these analytics engines could be twofold. One is once it gets some insights, it might try to get more data from the underlying probes. So it wanted to change the observability. So it might start with a shallow but broad level of monitoring initially, but as and when it detects some type of anomalies or some triggers happens, it wanted to change the observability such that now it wanted to do a deep observability for a subset of the narrow traffic. So that is one outcome of this analytics engine. The other one could be once it takes a full decision, it wanted to now apply the decision on the network elements in order to enhance or enhance the performance of that element. So that is the type of control decision. It will feed into the orchestration platform, which is nothing but our XOS and ONOS, to make that execute on the decision to be applied on those network elements, thereby closing the loop. So this is at a high level, all the four elements, how they combinedly provide this goal of deep observability and enabling the closed loop controls. So with that introduction, let me jump into the topic of this. That is the monitoring service. So as I was describing in the previous architecture, so monitoring as a service is a logically centralized service built as yet another service inside the Cord by following XOS, everything as a service principle. It is built to decouple analytics applications from the underlying probes, thereby to achieve a true multi-vendorness inside the Cord. We don't want the analytics applications to be locked down with the underlying probes. So decouple them by providing this abstraction so that let the elements publish the data to the monitoring service and let it expose to the applications. So that is our key goal. It allows multiple applications to consume the same data. That is another paradigm we have followed. That is collect once, use many type of approach. Instead of for each network element, you have your own proprietary application. We don't want to go into that type of model. Obviously, this type of approach will allow you to bring new analytics and new probes into this framework very easily. And by following the XOS principle, this is built as yet another scalable and multi-tenant service inside the Cord framework. So as I was mentioning, it followed the XOS service construction toolkit in order to build this monitoring service. So when I say XOS service construction toolkit, what I mean is it is where each service is composed of two elements. One is the service controller and the service instances. So a service controller is nothing but a combination of three components. So the service model, which holds the authoritative state of the service, and then a key API interfaces. It could be Tosca, REST, or admin interface in order to configure the particular service. And in the southbound, we have a synchronizer that keeps the backend service instances in sync with the authoritative state of the service. So combination of these three elements is what we are calling as service controller. So service controller, so this service controller part of the service will run on the head node as part of the XOS core platform. and the service instances are the one that runs on the compute infrastructure. So typical flow here is an operator or an analytics application interacts with the service controller through their exposed interfaces in order to create the service itself or to create tenants for the service. So when the, sorry, is there any question?
No, so could you, I think it would be helpful to get fairly quickly to how we can recruit people to participate. So the probe inventory, the user guide kind of information.
And Larry, is this can maybe extend on that? Is how dynamic services can be introduced, or maybe services can be modified.
So Tom's asking about dynamic programmable.
Sorry, I missed that question.
Tom wanted to hear about how dynamic the probes are, or the services.
No, today we don't have any dynamic probes yet, but the eventual goal is to make those probes expose some APIs so that the monitoring service can turn them on and off based on the application's input.
Srikant, this is Shishir. I am a new member here. I have a quick question on this. The monitoring service will be polling for the data from the devices, or the devices will be periodically sending the data to a monitoring service? What model are you planning to use?
Okay, it supports today the push model where the network elements are supposed to collect the data and publish it to the monitoring service. So that's where, if you see this particular diagram, the monitoring service exposes the RabbitMQ based transport in the southbound. So all the network elements need to publish their data to this particular RabbitMQ message queue.
So this picture is interesting because it shows all of the sub pieces.
Yes, these are the various components or software running inside that monitoring service instance. So when the service is deployed, you will find all these components running, which each of them performing different functionalities. So the RabbitMQ message queue is the southbound message bus where all the publishers can publish. And Ceilometer data handlers will consume the data from the message queue and parse, normalize, and transform the data. Once they normalize the data, now they need to determine where the data needs to go. So that is the data delivery part. So there are two parts here. One could be the path will go into the database. For historical reasons, you can keep this data. And the other path is where if application is interested in receiving notifications about the data, it will be published to a Kafka message bus, which will be published, which can be consumed by the applications. So these are the two delivery mechanisms that monitoring service supports it today. For the data, so once the data is stored in the database, we leverage the Ceilometer APIs, which leverages the keystone authentication in order to retrieve the data from the database. The beauty of this architecture, or for Ceilometer architecture, is it's little extensible, so that it's not just tied to one type of database. You can change it to HBase or Elasticsearch, or there are some new mechanisms to speed up the performance of the database part, or even you can put it in InfluxDB via another monitoring system called Munaska. So all sorts of possible.
Just a quick question: which parts of this are all of these parts running inside of instances, or are parts of these services on the head node?
No, everything is running inside the instance. So that's where the deployment model captures. Today, all these components run as a single VM, which runs on one compute host.
Thanks.
The eventual deployment is what I am showing it right now. So we wanted to, so all these components are like independently deployable. So there is no real need for keeping everything in one VM. So you can have your RabbitMQ cluster in one set of slice. Then you have data handlers in another slice. The first and foremost for the scale of monitoring services, you have to put database in a separate slice. because there will be a humongous number of reads and writes happening here. So we wanted to segregate that into separate slice and deploy it in multiple computes. The rest of the components are not as heavy as the database, but it's up to you if you want to keep them on separate slice or in a single slice. It's all possible.
Thanks.
Okay.
Yeah.
Yeah, I have documented all the necessary stuff to plug in your services into this monitoring service in the wiki and under analytics per Cord. Please take a look, and already MCORD team is following these instructions to plug in their test as a service to publish the results into the monitoring service and get it displayed in the dashboard. So it should be same for other services also. If there are any questions, yeah, you can reach out to me, and yeah, that's all.
So from a dashboard point of view, Mateo, how well is this integrated with? What's the latest state of the integration with the GUI?
So with the old GUI, it is completely integrated. You just need to load it. To activate it, it is loaded by default in all the system. And once you onboard the analytics service, you can just activate the view, and
so the view is
will
there.
be configured by the data that comes from the backend. So it doesn't really matter how many services you're watching to. And I'm going to integrate that view with the new UI soon.
So he's actually walking through the GUI. For those that have.
Yeah. So this is the current dashboard support that we have inside the Cord GUI. So as you see here, when you initially go to this dashboard, it will show you all the services that you are authorized to watch for. And then within each service, you can have one or more number of slices. For each slices, it captures what are all the resources that are part of that slice, and for each resource, what is the usage of different metrics that you are collecting. So for example, this is the service, the VSG service is where we are collecting both infrastructure level and the service level for the type of metrics. For example, if you see here, this is capturing the utilization of the virtual machine on which the VSG containers are running. But if you want to dig deeper into service level, what we have done is we just took some sample metrics published by the VSG container. For example, this guy is showing us the DNS cache size at different intervals, which is not infrastructure. This is more of service-specific KPI. So this is how it can capture or monitor both infrastructure and service level telemetry data. For example, this also can capture some of the networking infrastructure where we are getting infrastructure telemetry from the OVS switches on various compute node. So yeah.
So I have another question. One monitoring service instance will be managing how many such physical or virtual devices? Any idea?
We have not really done any benchmarking. It's not more than the number of elements. It's more of number of events that it can process.
Yeah, because this will generate huge amount of data in the management channel. So
no, this is not running on the management channel. This is on the VTN network. So if you see the architecture, it is running. Okay, I'm not sure. Yeah. So if monitoring service is running on the fabric network, so it is running on a VTN data network, and we are expecting all the services to publish their data over this channel.
okay.
Yeah, that's a really important point. Monitoring is just yet another service. We wanted to make it as minimal, require as little privilege as possible. You have to subscribe to it to use it as to publish your data, and you subscribe to it from the other end northbound to access its data. Are there other questions? So one of the pleas is, please consider adding monitoring probes to your VNFs, your hardware, your whatever, feeding data into here. And there's also plenty of work to do on the dashboard side, and Srikanth has some plans there. But if you're interested in getting involved, there's plenty to do there. And I guess beyond dashboards, we're not doing any serious machine learning or analytics. We're hoping that the community brings valuable analytics to the game. But if we had something open source that we could use to demonstrate, that would be great. Other questions? Okay, thanks, Srikanth. And an exemplary model of good wiki pages up to date.
So we search for, I guess, we can just go to wiki and search for monitoring. And
well, it's under Cord. I mean, there's,
okay.
Yeah, it's all under the Cord entry point.
Thanks.
And by the way, there are other collaborators now interested in monitoring, so we're going to try to bootstrap a bit more of a regular analytics Cord call so that we can get different people that are interested in this involved in it. It's been a little bit somewhat isolated, but more closely attached to Cord, but it's much broader than that. So I'll put out a call to see who's interested, and we'll try to find a time to do that.
So one of the things
we've
been talking about was a general purpose message bus. And I think an open question was whether the monitoring services message bus could be leveraged for that, or broken out as a separate service, the message bus, or maybe use different message bus. I'm curious if we want to have, you know, a single message bus for Cord, or whether we want to go down the path of different ones for different purposes.
Well, there's nothing here that requires one message bus. That it should be possible with multiple, but what I think is tempting is to say, I will set up a message bus and it will be privileged and it will run on the management channel because it's only being used between, for example, XOS, data model, and synchronizers and views. So that's a perfectly reasonable thing, but that is a privileged message bus only used in a single privileged trust domain. Now, maybe that's the right thing to do because it's optimized for exactly that purpose, but I would really like to push off onto a general purpose message system. I don't know.
So I think it will make our life easier to have just one message bus, but we have to be careful about privileges on that message bus, because if we allow access to random service to that, it can be a security issue. So we need to think about it.
Yeah, so I don't think there's a single correct answer. We already have a Redis message bus-like thing that we're using between the synchronizers and the GUI. So that's just going to happen. That's fine. But we have to avoid the temptation of continuing to generalize those when we already have a general purpose thing. If there's a very narrow use case, then that's one thing. But I would hope that we don't try to generalize too many examples.
So the context in which we've been discussing message buses with David is in terms of environment discovery. So a new switch comes online, and he was thinking that it would be good for the component that he's written that detects the new switch to be able to publish some event saying, here's a new switch and here's its information into the environment, and then other things that are interested in, you know, say provisioning switches or updating the data model with switch information could then listen on that bus and do their thing. So I think maybe the question is the monitoring service the place to do that kind of discovery and publishing information about new things in the environment? Or is the focus of the monitoring service more getting performance information about existing things in the environment?
Well, I'd be interested in hearing Shrikant's opinion. The monitoring service is intended to be general purpose, so I would think it could be used for discovery if there was a probe that was discovering and announcing that. It's a standard trade-off between, do I want to use a general purpose tool, or am I better served by specializing for this one case?
Okay, in that related monitoring service, what we are, I mean, my thinking was, if we can have a centralized message bus and a centralized database cluster, I'm planning to hook monitoring service into those two elements so that we can have a one cluster of message bus for entire cord. But again, this brings your point of how do you control the access privileges? Should we open up that message bus for all modules inside the cord or only for privileged components? That is one challenge we have. But the architecture of monitoring services can be aligned with, if we have a one cluster of message bus for entire cord, we can easily hook the monitoring service into that and consume the data. Second question is related to whether what type of events that monitoring service can receive, right? So I think David's point is about the switch discovery, which comes at much earlier in the process before even monitoring service is up and running in the infrastructure. How would that even work? I don't know. Is it about the existing switch discovery or a new switch discovery? New switches can be discovered if monitoring service is already in place and can consume it. But if it is also required for initial bringing up of the initial fabric, then I don't know.
Right. So I think you're right, Srikant, that there's a bootstrapping issue here that we've been talking about switch discovery in terms of the initial switches that are coming up to bring up the fabric. And so until that happens, presumably we can't bring up the monitoring service. So we would need some other, if we were going to publish events about those switches coming up, then we would need some other message bus to already be bootstrapped at that point.
Right.
Another point is that we are going to use protobufs and gRPC service to communicate between XOS services, and that architecture offers us the ability to have streams inside the system, so that may be a good place to send events about switches and about notification in the data model.
Yeah, I suspect we will end up with multiple narrowly targeted solutions here. So I think everyone is going to, not everyone, there will be a very strong temptation to say, I'll do it myself. And I need a message bus, I'll set one up. I just wanted to make sure everyone is aware that there is a general purpose mechanism that includes a bus-like facility, and it archives your events. It won't be running at bootstrap time, so that is the limitation. But you should ask yourself, do I really need another message bus, or would this serve my purposes? And if you got a strong case for, no, I need something else, and that's fine, that's to be expected.
But Srikant, it sounded like, so I'm just trying to channel David here. It sounded like if there was a message bus that was brought up at bootstrapping time that was intended to be some general purpose message bus, then your framework could just hook into that bus.
Right. That would be the ideal deployment. We don't want to instantiate multiple clusters of message buses and data bus. Yeah. If it is already existing in the environment, we wanted to hook it on.
So can I say that a different way? An existing message bus could be a source of data that feeds into the monitoring service. Is that the way you're thinking of it?
No, we want all the elements in the cord to publish to that message bus so that monitoring service will consume the data and process and normalize and make it available to the higher layers.
Yeah, so the way I was thinking about it, maybe I don't quite understand, is one component of the monitoring service is a message bus, and it needs that to work. And so right now it's setting up its own, but if there was a pre-existing one, then it could use that instead.
Well, so now this is for the consumption of the data, not the producing of the data. So the monitoring service doesn't have a message bus, but it's got RabbitMQ as a place to inject events into the monitoring service. And it has Kafka as a way to pull data out of the service. Where were you putting your other message bus?
So the southbound message bus that we were talking, right, the RabbitMQ, eventually we don't even want to RabbitMQ, we wanted to have a single Kafka bus inside the monitoring service to which all the elements will publish their data, and the monitoring service components will consume the data from that Kafka message bus and process and normalize and again republish to the same Kafka bus from which services can consume the data. This should be our eventual goal. Now what we are saying is instead of monitoring service deploying its own Kafka message bus, let's have a centralized Kafka bus for entire Cord. Kafka is, you can create multiple topics so that you create one topic for monitoring service or somebody else can create another topic for the switch discovery events. And monitoring service can listen on whatever configured topics and consume the data and process it. That is the model I believe Andy was referring to.
Thanks. Would it have the same multi-tenant, restricted access capability? Because that goes beyond what Kafka would limit you to naturally.
Yes, that should be still possible. That multi-tenant and tenancy based configuration is still possible. Yeah.
Okay.
And is it correct that this bus is inherently unprivileged?
Yeah, that's where my question. Yeah, whether should we make it as unprivileged or how do we control these privileges? Access to this message bus is the challenge that we need to solve before going into that model.
So the way I was looking at it, there is already, the monitoring service gives a solution for multi-tenant access control to the data from the analytics. But if you already had a privileged bus that was being used internal to Cord, perhaps on the head node, between XOS or whatever, that could be a southbound source of data. And then the privileged issue isn't the same. It's just
that means the third-party services also should have access to that Kafka message bus because they need to publish their data to that message.
Yeah, you're right.
So we could implement some kind of a gateway between the privileged bus and the unprivileged bus that restricted what messages could pass through, either forcing traffic to be unidirectional or allowing restricted bidirectional traffic if we wanted events on the privileged bus to be visible inside the monitoring service. Is that an appropriate approach?
Yeah, except monitoring is already trying to collect data from everywhere, and then it enforces privilege on who can get data out. Right? It's taking counters from hardware if it can get them. That's pretty privileged data. All right, so there are some design issues here to think about, but hopefully everyone sees what the issues are. Other questions? Are there topics?
That bus you mentioned, Larry, that this for getting the emails, etc., into that bus so people can connect. That could be like some kind of memory map in XOS or some ONOS or somewhere, right? So various collectors can, depending on the policy, they can post their stuff into that memory map so others can reach out.
Well, it's a bus because it's distributed. It's not going to be a memory map as an implementation.
But if it's a bus, you're going to lose it if you don't take it or if you don't collect it or whatever.
Well, the monitoring service is supposed to be there picking it up.
I see this. Okay.
So it should be fine. Okay. Any other topics? Ready to adjourn? Okay, that's it. Thank you, everyone. Thanks, Shrikant. See you next time. Bye.